Now we are going to discuss about the solar cell. It is a junction diode which convert solar energy into electrical energy. Its working principle is exactly similar to that of the photodiode. Only difference is that a photodiode is connected in reverse bias. A solar cell is not given any biasing voltage. The working of solar cell is exactly similar as that of the photodiode, but we know that a photodiode is reverse biased. A photodiode is connected in reverse bias, but a solar cell is not given any biasing voltage. It supply EMF like an ordinary cell. It supply EMF like an ordinary cell. Okay? So this ordinary cell is used to store this ordinary cell is used to charge the secondary battery. Do you know the secondary battery? Okay? Like photodiode, solar cell is also based on photovoltaic effect. When light of suitable frequency is made incident on an open circuit solar cell, an EMF is produced across its terminal. While this EMF is called photovoltaic EMF and the effect is called photovoltaic effect. And this solar cell we can use a set of solar cell to charge storage batteries, that is the secondary cell, in daytime, and these batteries can be used for the power during the night. Normally solar cells are used to charge the secondary batteries in the daytime, and these batteries can be used during the night for electrical power. The solar cells are also used to power electronic devices in artificial satellite and the space vehicle. If you see any artificial satellite or space vehicle, you will see some solar panel extending up to 5 to 10 kilometers. And these solar cells are basically convert the solar energy into electrical energy, and this electrical energy are used to charge the storage batteries in the daytime, and during the night the current is taken from these batteries for some activities. Solar cells are also extensively used in calculator, wristwatch, light meters. In photography also the solar cells are used. Okay? So basic difference between solar cell and that of photodiode is that a photodiode is reverse biased, solar cell is always connected in, solar cell is not given any biasing. So this is the symbol of the solar cell. That means when light falls on the PN junction, the positive side of the semiconductor act as a positive terminal and negative side act as a negative terminal. This is the symbol. So this is the circuit representation. This is the load resistance. When the light falls, a current flows through the junction. A current flows through the junction. When light falls on the junction, a current flows through the junction. And a current flow through the junction, and this current is used to charge the storage battery. Okay. Normally, over the P type of the crystal, P type of the semiconductor, a thin layer of N-type semiconductor is formed. Okay, have you seen this type of? These are the finger type electrode. When the light falls on the junction, this finger becomes negatively charged and this finger becomes the positively charged, because this electrode is connected to the P side and this electrode is connected to the N side. Okay, how this end becomes negative, this end becomes positive, because when light falls on the junction, having energy slightly more than the energy gap between valence band and conduction band, electron makes jump from valence band to conduction band. Electron ne tumar ki koribo, jump koribo from valence band to conduction band. As a result, equal number of whole electron pairs are created. Actually, working of solar cell depends on three phenomena. One is generation, one is separation, and one is collected. Generation of whole electron pairs are due to excitation of electrons from valence band to conduction band by light photons near the junction. Separation of electron and holes are due to the electric field of the depletion region. We know that across the PN junction, an electric field is there, which is called contact electric field, and that electric field directed from N side to P side. When the light falls on the junction, equal number of whole electron pairs are created. As a result, the holes are moving towards the P side and making P terminal positive, and electrons are towards the N side and making N terminal negative. So separation of whole electron pairs are due to the electric field at the junction or at the depletion region. Electrons are swept towards the N side and holes to the P side. The electron reaching the N side are collected by the front electrode. Front electrode means this electrode, and holes reaching the P side are collected by the back electrode. This is the P side, this is the N side. Okay. Thus, a photovoltaic creates across positive P side and negative N side of the junction. How the current is generated here. When the light falls on the junction, the electron make a jump from valence band to conduction band. When light photon having energy slightly more than valence band and conduction band falls on the junction, equal number of whole electron pairs are created due to the excitation of electron from valence band to conduction band. Okay? So therefore, this is the generation of whole electron pairs. Now, at the junction of the semiconductor, an electric field is there. So that is called contact electric field, which is directed from N side to P side of the crystal, Therefore, electrons are collected towards the N side and holes towards the P side. Because we know that electrons always move opposite to the direction of electric field and holes are moving towards the direction of electric field. So therefore, that is called separation. Separation of whole electrons are due to the electric field of the depletion regions. Electrons are swept towards the N side and holes to the P side. The electron reaching the N side are collected by the front electrode. Front electrode means this front electrode, and holes swept, holes collected, holes reaching the P side are collected by the back electrode. Thus, a photovoltaic creates across positive P side and negative N side of the junction. Thus, a photovoltaic creates across positive P side and negative N side of the junction. When a load is connected, a photocurrent flows through the load resistance. When a load is connected, a photo voltage flows, a photo current flows through the load resistance. The load may be a storage cell, and that particular current charges the storage cell during the daytime. So this is the IV characteristic. This is the IV characteristics of the solar cell. It is found that the IV characteristics of solar cell, is in the fourth quadrant. This is called open circuit voltage, and this is called short circuited current. ISC, short circuited current, and this is called open circuit voltage. Sometimes a question asks, why IV characteristics of solar cell is in the fourth quadrant, and IV characteristics of photodiode is in the third quadrant. মই আগেই কৈছিলোঁ যে working principle of photodiode and that of solar cell are exactly same. Only difference is that solar cell is not connected across any biasing battery. Solar cell is not biased. But we are not giving any biasing voltage to the solar cell, but photodiode is reverse biased. Solar cell is not given any biasing, but photodiode is reverse biased. Therefore, the IV characteristics of photodiode is in the third quadrant, but IV characteristics of solar cell is in the fourth quadrant. The IV characteristics of a solar cell is drawn in the fourth quadrant. This is because a solar cell does not draw any current. Solar cell current draw no kore, but supply the current to the load, and because of this fact, a factor karone je tumar ki hoy IV characteristics to tumar ki hoy je IV characteristics to tumar fourth quadrant ot ahe. tar mane tumar ki hoy solar cell ot tumar ki hoy, so solar cell ot ki hoy যে P side to positive হৈ যায়, আৰু N side to negative হৈ যায়. তো সেই কাৰণে আমাৰ ইয়াত চোৱা P side to কিয় পজিটিভ হয়, কাৰণ হোলছ বিলাক কি হয় P ৰিজনলৈ আহে, ইলেক্ট্ৰনছ বিলাক N ৰিজনলৈ আহে. তাৰমানে এইটো দেখাত মোৰ এনে ফৰৱাৰ্ড বায়াসিং কণ্ডিশ্যনটোৰ দৰেই হ'ল, P পজিটিভ, সেইকাৰণে তোমাৰ চোৱা ভল্টেজটো পজিটিভ ভল্টেজত গৈছে, পজিটিভৰ চাইডত গৈছে, আৰু কাৰেণ্টটো ৰিভাৰ্সৰ ফালে আহিছে. কাৰেণ্টটো চোৱা মাইক্ৰ' এম্পিয়াৰত আছে. Why in microampere? Because a very few number of whole electron pairs are created. Very few, because due to the contact electric field, only minority charge carriers can move. Yes or no? গতিকে যে তোমাৰ ইয়াত তোমাৰ কি হৈছে, কাৰেণ্টটো মাইক্ৰ' এম্পিয়াৰতে আছে. কাৰেণ্ট ইজ ইন মাইক্ৰ' এম্পিয়াৰ. তোমাক সুধিব পাৰে why the current is in microampere. এটা ক'ব লাগিব যে very few number of electron hole pairs are created at the junction when the light energy falls on the junction, and because of that the current is in the microampere range. তাৰমানে তোমাৰ এইটো এন নিগেটিভ হৈ যায়, এইটো এন পজিটিভ হৈ যায়, সেইকাৰণে ভল্টেজটো তোমাৰ কি হয় এলং দ্য পজিটিভ এক্সিছত যায়, আৰু কাৰেণ্টটো তোমাৰ কি যায় এলং দ্য নিগেটিভ এক্সিছ. কাৰেণ্টটো তোমাৰ এলং দ্য নিগেটিভ এক্সিছত যায়. আৰু আউটসাইড দ্য সার্কিট কারেন্ট flows from positive to from P side of the crystal to the N side of the crystal. এতিয়া মই যিটো বেটাৰী মই কি কৰিম চাৰ্জ কৰিম, এই বেটাৰীৰ পজিটিভটো ইয়াত কানেক্ট কৰি দিয়ে আৰু এইটো বেটাৰীৰ নিগেটিভটো ইয়াত কানেক্ট কৰি দিয়ে. এইটো কমপ্লিটলি আনচাৰ্জড বেটাৰী আছিল, ইয়াৰ একচৰ কোনো পটেনচিয়েল ডিফাৰেন্স নাছিল. তো ডিউ টু দিছ পজিটিভ, ডিউ টু দিছ কাৰেণ্ট তোমাৰ কি হ'ব, এই বেটাৰীটো চাৰ্জ হ'ব. আমি কাৰেণ্ট ইলেক্ট্ৰিচিটিত পাইছোঁ নহয়. ডিউৰিং চাৰ্জিং প্ৰচেছ ইনচাইড দ্য বেটাৰী কাৰেণ্ট ফ্ল'জ ফ্ৰম পজিটিভ টু নিগেটিভ. ডিছচাৰ্জিঙৰ সময়তে কি হয়, কাৰেণ্টটো কি হয়, নিগেটিভ টু পজিটিভ যায়. চ' ইয়াত আমি এইটো বেটাৰী চাৰ্জ কৰিব লাগে নহয়, এইটো বেটাৰীৰ পজিটিভটো পি চাইডত কানেক্ট কৰিম আৰু নিগেটিভটো এন চাইডত কানেক্ট কৰিম। এজ এ ৰিজাল্ট কাৰেণ্ট ইনচাইড দ্য বেটাৰী ফ্ল'জ ফ্ৰম পজিটিভ টু নিগেটিভ। এজ এ ৰিজাল্ট দিছ বেটাৰী গেট চাৰ্জ। অ'কে, নেক্সট, the material used for fabrication of solar cell. The semiconductor with band gap which is close to 1.5 electron volt are ideal material for the purpose. The semiconductor having band gap close to 1.5 electron volt, close to 1.5 electron volt are ideal material for the fabrication of the solar cell. Actually, তোমার কি হয়, the important criteria for selecting the materials are band gap should be 1 electron volt to 1.8 electron volt, electrical conductivity and availability of the low material. The important criteria for the selection of material for fabrication of solar cell. The band gap to 1 electron volt to 1.8 হ'ব লাগে, কিন্তু বেছি ভাল তোমাৰ কোনটোত হ'ব, বেছি ভাল কোনটোত হ'ব যাৰ বেণ্ড গেপটো নিয়াৰ 1.5 ইলেক্ট্ৰন ভল্ট হ'ব। অ'কে, the best materials we may use silicon semiconductor also to make the solar cell because band gap is 1.1 electron volt. Gallium arsenide semiconductor, its band gap is 1.43 electron volt. So therefore these materials are suitable for using the suitable for making the solar cells. What is the advantage of solar cells over the other processes? The advantage is it is a pollution free, long lasting and maintenance free. They can be used anywhere as a self generating source of electricity. But only one point, the solar cell have high cost of installation. Only one disadvantage is that its cost of installation is slightly more. One question comes more frequently: why cesium and gallium arsenide are preferred for construction of solar cell? It is because the solar intensity received is maximum near 1.5 electron volt. The solar intensity received is maximum near 1.5 electron volt. Since for photo excitation, energy of incident photon should be slightly more than the energy gap between conduction band and valence band. Since for photo excitation, energy of incident photon should be slightly more than the energy gap between conduction band and valence band. Hence, semiconductor with band gap near 1.5 electron volt or lower gives better solar energy. সেইকাৰণে কি হয়, যিবিলাক সেমিকন্ডাক্টৰৰ এনাৰ্জি গেপটো 1.5 বা তাতকৈ অলপ কম, so these materials give better solar energy. Since energy gap of silicon is 1.1 electron volt and gallium arsenide is 1.43 electron volt, they are most commonly used for the construction of solar cell. A question to khub ahe, why silicon and gallium arsenide preferred for the construction of solar cell.